So you might have to solve intersections between linear and quadratic graphs. Really similar to what we were doing before when you solve intersections between linear graphs. You would make sure that the two y's are equal. So this line here, you need to make sure that the linear y and the quadratic y are equal, and then you just solve for x. And then once you solve for x, you substitute it into the y. I would suggest you put it into the linear equation rather than the quadratic when you solve for x, because if you solve it for the quadratic one, you then have to square it, which means you might get numbers wrong. If you have the linear one, you simply just multiply it, which is a lot more straightforward. Okay. The other thing you might also see is how many times it intersects between the graphs. So if you look at the one on the left, there's no intersections, right? If you were to find the determinant for that, what number would you need? It's either equal to, greater than, or less than 0. Which one? Less than 0. Okay. If you have one point of intersection, what would happen? Equal to 0. And then if you have two, greater than 0. All right, so find the coordinates of the points of intersections between these two. What do we say we have to do first? And then make sure that what? It's y equals to the rest, right? So then once you've got that, make the two y's equal. So 1 plus x equals x squared minus 3x minus 4. And then how can I solve that?
X minus 5.
Good. If you can't find it, what would you do? If you can't find the factorization? Yeah, the quadratic equation, okay? Otherwise, you can just factorize and solve it if you can. Find your two values, substitute it back in. So y equals to 1 plus x, which is 6. Any questions with that? It's fairly mechanical and straightforward, yeah? Yes. It's already on OneNote. That's it. It says find the coordinates of the points. Have I found the coordinates of the points? Yep, so I'm done. That's it. Okay. Would you like me to show it to you on the CAS? Yeah? Oh, quickly. Okay, how many points of intersections are there between 2x minus 5 and y equals to 2x plus 5 plus 6? As I said before, we need to use what? To check whether or not there are any intersects. Same with the quadratic graph, what do we need to check? What's this again? Discriminant. So, before we get to the discriminant part, we need to make these two equal. So 2x squared plus 5x plus 6 equals to 2x minus 5. Rearrange it. Use your discriminant, which is what? V squared minus, okay, then put in your values. I should write out the ones in between. So 3 squared minus 4ac, we have 9 minus 88, giving us negative 79. So how many points of intersections? None, right? Because that's less than 0. Oh, whoops. Zoom out. There you go. Okay.